This is a schematic of a temperature terminated defrost timer. Here's a condensate pump. A lot of air conditioning technicians call these Little Giants just because Little Giant's the brand that most people buy. The condensate pump does a couple things. If you have an air conditioning in your home on the first floor that's landlocked, which means there's no outside wall touching it, you have to get the condensation that is made by your air conditioning system out of the home. So it drops into this pump. The pump has a hose going off. It will pump it outside, going up into the attic or wherever to get it outside. This is also used for defrosting water. When a freezer goes into defrost, that water has to go somewhere. If, again, it might not have an outside wall just to pour out, so they have to use a pump to remove it from the area. And these are normally activated by a float switch. Caution. Since defrosting results in moisture that could promote the growth of bacteria, mold and mildew, and algae, it is important to clean evaporator drain pans and drain lines frequently. Hot gas defrost system. Now, in the last PowerPoint I mentioned how home freezers have a tube of hot refrigerant that runs around the outside. Now that constantly happens every time the compressor runs because it wants to keep the door from freezing to the sidewalls. In this system, this is a larger tube that runs around the evap coil, and what happens is the unit switches from refrigerant sent to the evap coil to get it to get cold. It sends that little bit of hot refrigerant line to the outside of that coil and defrosts the coil, and then it shuts that switch off, closes the solenoid valve, and then goes back into normal operations of cooling the coil inside. Type of hot gas defrost system: low pressure, adjusting hot gas defrost systems. Reverse cycle hot gas defrost systems, that's kind of like a heat pump. And reverse cycle hot gas defrost for multiple evaporators. Sometimes they'll have one system just for defrosting, like in a large warehouse with a lot of evaporators in it. They'll have one system that just runs the defrost cycle. Less failure involved with switching reverse directions on these valves. This valve is just constantly sending some refrigerant to it when it calls for it. Again, these diagrams you can see better in the textbook. Reverse cycle hot gas defrost system for multiple evaporators. So this is, again, what we just spoke about. Take a look at it in your book. So it has one compressor that actually sends the refrigerant to multiple units. Here's another way to take care of the freezing of a coil. Non-freezing solution defrost system. It actually circulates a chemical through tubes around the coil to help defrost it, not refrigerant. It's not part of the cooling system. It's a separate system altogether. Then methods for heating the solution would be either hot gas or electric. Non-freezing solution defrost system. Again, it's hard to see on this, but you may look at it in your book. Water defrost system. Tap water runs over the evaporator during the off cycle. Manual or automatic system. Water drip or spray to melt the ice. Water must be drained completely before turning the unit on to prevent freezing. Some systems use lithium bromide brine solution. This is that solution we talked about earlier. It doesn't freeze very fast, but again, the system has to have time to get the water off the coil, because the minute it comes on, it's going to be, especially if it's a low temperature system, it's going to freeze up immediately. Electric heat defrost system. Electric heat coils in or near the evaporator. Sometimes they're just run completely over all the evaporators depending on how much they have to defrost and what short of time they have to do it. Elements underneath the vap coil, underneath the drain pan, and along the drain pipe. That's to keep that all from freezing up inside. Because again, these units will defrost, lose a lot of water. Sometimes the electric element is running right down the drain to the outside. Double wall tube within a tube, evaporators. This is where they have two tubes that run together, one inside the other that uses the defrost fluid. Off-cycle defrost system circulates air from the conditioned space over the evaporator during off-cycle. Evaporator fans continue to run to circulate the air. Heat in the air will melt the frost. Can only be used in an air-conditioned space that is above freezing. So you couldn't use this in a freezer. It would take forever for this to do this. But if you're in a system where your coil might freeze up because of certain conditions that you want to take a lot of humidity out of the air, then this blowing across the coil for 10 minutes, you're not going to change the air temperature a lot in the confined space, or conditioned space rather, but it will defrost the coil. Pump down defrost system. Refrigerant is removed from the evaporator to expedite defrosting, so it's actually going to pump the refrigerant out of that coil, so there's no refrigerant in it. It's just going to pull a vacuum on it. A refrigerant is stored in a liquid receiver, and we've covered some of those in the last chapters. Often uses conjunction with other methods defrosting, such as electric heat defrost. Condensers. Removes heat from a circulated medium, removes superheat from refrigerant, condenses vapor to a liquid, subcools high-pressure liquid refrigerants, air-cooled, water-cooled, and evaporative-cooled types. Air-cooled condenser. Heat is moved from the refrigerant by air, natural convection, or forced draft. So you could just put a coil in the open, say on a roof, normally in shade, and just the air outside will cause that coil to be, the temperature to drop. It all depends on the size of the coil. Or it has a fan that blows the air across it. Typically installed outdoors or outside walls, roofs, pads on the ground level, or brackets on a platform. Water-cooled condensers. Heat is removed from refrigerant by flowing water. Flow of water is controlled by an automatic water valve. Better heat transfer than air-cooled. Three basic types is shell and tube, shell and coil, tube within a tube. Uses water-cooled condensers, depend on access to water and associated cost. In the state of Florida, we probably have more water-cooled systems than anywhere else in the country, because you know we have water everywhere. Usually if you're near a lake, you can run a copper line into the lake, and it's not actually pulling lake water, but it's circulating the refrigerant or water that's cooling other refrigerant through the lake, just to drop the temperature of the water that's inside the coil. It doesn't mix, and uses that to cool your condensing unit. They're very efficient, usually up to 10 C or greater than air-cooled. Here's a diagram or a picture of a shell tube condenser. Again, you separate the water that cools it from the refrigerant by the refrigerant inside the copper tubes. Shell and coil condenser. Again, the cooling water goes through the tube inside the system with the liquid refrigerant, and it cools the liquid refrigerant, which is the red substance, and the water is running through the light to dark blue substance. Tube within a tube. They actually have a tube of refrigerant, and then inside that tube of refrigerant there is a water tube. So wherever the refrigerant goes, the water is in the center of that coil, removing the heat off that refrigerant. Evaporative condenser uses spray water droplets and drafts from fans to cool the coil. Configurations are counterflow design, combined flow design. Operational considerations designed to handle wide load variations. Capacity control is possible through the fan cycling on and off. Here's a diagram of an evaporative condenser, and you can see more in the book. Residential air conditioning condensers mostly are used air-cooled. You see very few water-cooled, maybe 2%. Varies widely by manufacturers. All of them look different, all of them different shapes. I've even seen ones that look like a table where the fan was on the bottom and the coil was on top and allowed the air to suck air from above through the bottom. Housing protective fins and tubing fans positioned for maximum airflow in coils. This is real important. You see a lot of pictures in videos and things where guys are setting their tools on top of the fan. You shouldn't do that. It blocks airflow. So if you're trying to get an accurate feeling of how it's charged and how it's working, blocking some of the air is not a good thing to do. Commercial air conditioning condensers are mostly air-cooled. Same function as a residential, and varied widely by manufacturer. We have units on our roof of the school that kind of look this way. They're not as big as this, but they're just condensing units usually.